Ocean currents. The third type of movement that takes place in the oceans is known as an ocean current. Streams of water move along the surface of the ocean in definite paths. Such more or less permanent streams of water which flows in a definite direction from one part of the ocean to the other are called ocean currents. Ocean currents can be thousands of kilometers in length and sometimes about 200 kilometers wide. Currents that originate near the equator and flow towards the poles are called warm currents, and those which originate in the high altitudes and flow towards the equator are called cold currents. Ocean currents are generally named after the regions along which they flow. The warm ocean current flowing along the Brazilian coast is called the Brazilian current, and the cold current flowing along the Labrador coast is known as the Labrador current. Ocean currents are powered by the wind system of the world. The wind systems of the world force the surface water of the oceans to move in a particular direction. A surface current of warm and light water flows from the equatorial region towards the polar region, and a cold current flows from the cold polar regions to the warm equatorial region. The prevailing winds lend speed and direction to a mass of water. Ocean currents in the northern hemisphere deflect to the right of the wind direction, and currents in the southern hemisphere deflect to the left. Therefore, there is a clockwise circulation of water in the northern hemisphere and an anti-clockwise circulation in the southern hemisphere. This is a Coriolis effect caused due to the rotation of the earth. Surface motion of prevailing winds drives the subsurface layer at an angle to it. Each layer moves at a slower speed than the one above it and at a greater angle from the wind. The spiral thus created has the overall effect of moving the water mass above the depth of frictional resistance at an angle of about 900 from the wind direction. This is called a Coriolis effect. The temperatures are higher at the equator than at the poles. Hence, water in the oceans near the equatorial regions gets heated more than the one in the oceans near the poles. This unequal heating sets up convectional currents in the ocean. Warm waters of the equatorial regions are light and move along the surface towards the polar regions, where they are cooled, while the cold water is dense and heavy. It sinks downwards from the surface and moves slowly towards the equator, where on warming up it may rise to the surface again. By the inflow of fresh water from rivers, melting ice, and rainfall, as well as evaporation. A current of normal salinity flows in, and the one of a higher salinity is carried out by a deeper water current. For example, a high rate of evaporation in the Mediterranean Sea increases the salinity and therefore the density of the water. As a result, a current of less dense, that is, less salt water, flows into the Mediterranean from the Atlantic and the Black Sea, while smaller currents of higher salinity flow outwards beneath these currents so that the salt content of the basin remains constant. Other factors affecting currents are the configuration of the ocean bed and the shapes of land masses. For example, in the Atlantic Ocean, the North Equatorial Current flows towards the West Indies. Most of the current is channeled into the Gulf of Mexico, where it veers northeastward, bursting into the Atlantic Ocean between Florida and Cuba as the Gulf Stream. Each ocean has its own system of ocean currents. The ocean currents of the Atlantic Ocean and Pacific Ocean show a common pattern. Ocean currents originate in the equatorial regions as the warm equatorial currents and flow westward. When they encounter continents, they divide into two branches. One is deflected northwards and the other southwards. These warm currents move along the east coast in the low and middle latitudes. As these currents reach the higher latitudes, they move across the ocean and turn towards the equator, washing the western margins of continents. But this time, the warm current loses much of its warmth and flows along the west coast as a cool current. Finally, the current warms up as it reaches the equator and becomes a part of the equatorial current. The currents of the Indian Ocean differ from those of the Atlantic and the Pacific Oceans, mainly because of the enclosed nature of the sea and the influence of the monsoon winds. In the northern part of the Indian Ocean, the direction of the current changes according to the season. In summer, when southwest monsoon blow, the current flows in the western direction, and in winter, when the northeast monsoon winds blow, the current flows in the eastern direction.